Hello, everyone. My name is Tom Johnson, and I'm the director of the EOGOGICS Web Live programs. Having been involved in computer-based training in one form or another for more than 25 years now, it's my pleasure to welcome each of you to this Web Live session. For those of you who may be new to EOGOGICS, I'll refer you to the About EOGOGICS page on our website. Suffice to say that the EOGOGICS team, led by KK Aurora, has been involved with many landmark telecom projects worldwide during the last 20 years or so. In fact, I think KK is in our audience here somewhere. KK, are you there?
Yes, I am, Tom. Good afternoon and welcome to the class.
Well, thank you, sir, and introduce our presenter today. Frank Ortman is a principal member of the EOGOGICS telecommunications faculty. You can view his detailed bio on the website, but I'd like to say just a few words by way of introduction. Frank teaches the EOGOGICS courses on 4G, WiMAX, Wi-Fi, SIP, and VoIP. He also provides consultation on RFP design and vendor selection to those involved in implementing broadband networks as part of the BTOP program that's included in the Economic Stimulus Act. Frank's teaching and consulting career builds on his 20-plus years experience in the telecommunications and electronic warfare areas. A firm believer in learning by doing, he even operated a small WiMAX network of his own for a while, which I thought you might find interesting. Frank has published several research reports and 4 books covering topics such as WiMAX, Wi-Fi, Voice over IP, and the emerging all-IP architecture. And now, without further ado, Frank Ortman.
Yes, good morning, good afternoon, good evening, wherever you may be, and welcome to LTE, a 1-hour mini course for all audiences, a web live presentation. One quick piece of housekeeping: intellectual property rights remain the property of EOGOGICS and the presenters. Well, let's jump right in here. And if this were live, I'd say, let's see a show of hands of people who have an iPhone, and not to pick on that particular brand of smartphone, but some of the concerns coming up in the press these days is that some of the calls get dropped and the internet throughput may not be what everyone expected. So because of that, I call this Why Your Smartphone Doesn't Work the Way You Think It Should, an overview or an introduction to LTE and 4G. Is your smartphone as smart as you would like it to be? Does your phone drop calls? Are the downloads not as fast as you think they should be? Is the service advertised as 3G or third generation? And maybe if you're not achieving the satisfaction you thought you would, the question becomes, perhaps the devices are here, i.e. 3G or 4G, but perhaps the network is not. So that brings on the question as to what has to happen before the smartphones can perform as quote-unquote promised or to our satisfaction. Let's talk about 4G and its relationship vis-a-vis LTE or long-term evolution. 4G is a marketing term. It is not a standard. So the guidelines will be somewhat loose as to its definitions and what the benchmarks might constitute 4G or fourth generation. So LTE is a standard being developed within the cellular industry, mostly by vendors and service providers. It will provide more bandwidth than what we see on third generation or 3G networks. It is mobile. It is all IP, or we like to call that flat architecture. And per the specifications, it should offer only voice over IP and not circuit switched voice. Probably the easiest way I have found over the years to describe anything related to telecommunications networks is the 3 A's. Access, what is the technology for accessing the network? Applications, what is the technology to be used for? And ultimately, affordability, that is the money portion of it. Does using this technology make business sense? Let's start out with access. For LTE technologies. And the best way to approach this is sort of the usual issues, the usual objections might want to get for wireless applications vis-a-vis wired or wireline applications. And so the question might be, will there be adequate bandwidth? Will I have adequate quality of service to support voice, video, and other time-sensitive, QoS-sensitive applications on it? And very importantly, what about interference? With LTE, it's a question of having more bandwidth, good quality of service, less interference, thanks to technologies such as OFDM, orthogonal frequency division multiplexing, and MIMO, multi-in, multi-out. So let's greatly simplify OFDM. So without OFDM, or until now, or what we might have seen within previous cellular and other wireless technologies, is a limited distance and throughput that the signal is susceptible to interference. But with the introduction of OFDM, we overcome a lot of those issues to offer the maximum distance and throughput accompanied with a resistance to interference. So how does OFDM work? Let's look at the figure on the left-hand side, a single carrier, which is the typical means of a wireless transmission dating back to when, 100 years ago, when Mr. Marconi sent his signal across the Atlantic, his telegraph signal across the Atlantic, the first wireless transmission to do so. And the figure on the right-hand side, multiple carriers. In one example, there are many of this. OFDM was originally patented in the United States in 1957. So instead of carrying one channel of 72 megabits of data, 48 sub-channels carry that out, each with 1.5 megabits of data. One of the immediate benefits on that is overcoming multipath interference, also known as inter-signal interference. Well, how does LTE and OFDM work? A really unique thing about LTE is that the downlink is OFDM and the uplink is a single carrier. The protocol for that one is single carrier frequency division multiple access. And a little note on the competing technology to LTE is WiMAX, and WiMAX is OFDM up and down. So just a graphic demonstration of how that works between the subscriber device and the base station. Downlink to read OFDM, and the uplink is single carrier frequency division multiple access. And part of OFDM is modulation schemes. And here's a graphic representation of the value of modulation scheme, thanks to friends. If we look at this screen on the right-hand side, close to the base station, we can enjoy the highest bandwidth, the highest throughput, the highest quality of service, the highest signal strength, thanks to quadrangular amplitude modulation, or QAM64. Now, then, as we get farther away from the base station, the signal starts to degrade somewhat, and we slip to QAM16. So our throughput isn't quite as robust as it was at QAM64. Then we go out a little bit farther, and the signal drops to using a modulation scheme called quadrangular phase shift keying. And that goes on a little bit further, and then we drop down further to BPSK, basic phase shift keying, and so on and so forth. So yes, our throughput might decline over distance, but the point is that we are still getting a strong enough signal to offer a commercial grade service. How do we ensure quality of service over a wireless technology such as LTE? Well, that's where OFDM and modulation schemes help us achieve that to ensure good QoS to deliver voice, video services, i.e. time-sensitive, QoS-dependent services.